Hello, David. Is that a recent edition or an older one? Your picture shows a small baby and you're on mute, so I don't know if you're trying to talk. Hello, Jerry?
Hello, everyone.
Hello, Keith.
Hey, Keith. Hey, everybody.
Hi, Greg. Thanks very much indeed for your input, Greg, on the document that we've been chatting about. So I appreciate it.
Well, yeah, it's been so long since I did it. I barely remember doing it.
I'm sorry, it can't have been more than a week or two, but I only just got around to it. I've been putting it off to have other stuff I need to get done. So I've been having
it has been the last couple of weeks. You're right.
Been having I think a fruitful, certainly quite to and fro-y conversation with Alec Fernandez, which has been useful as well, I think. So that's good.
You're gonna make me go dig up the link again so I can remember what I said.
Oh, maybe I could just make up what it is you said. No, it was good stuff. I think I've addressed pretty much everything people have to say. So we'll see.
Okay, so we're a few minutes past. Let's go ahead and get started. I lost my window. Huh? So do we have Usama here yet? Yes, we do.
We do. I've seen it here.
So I think what we have on the agenda this morning is continuing some conversation from last week there. So Swan, you want to go ahead and pick that up? I think we were talking about the RITLS when we stopped last time.
Yeah, I was. Yeah, hello. Thank you, Keith. We were last time discussing about a different topic, but that was more about specifications. But if it's fine, I would quickly like to first talk about RITLS. We had some discussions with Intel, and I'm just seeing that at least Ned is here. Probably someone else might also join. So it's kind of a pulse check for the project. We all know that Shanwai has retired, and what are the next steps for this specific project before we go to continue the topic that we were discussing last time? Is it fine to first talk about this?
Yeah, well, let's go ahead.
Okay, perfect. So I will quickly share. Okay, so I have just a couple of slides, basically a summary of what we had discussed with Intel and what came up. And yeah, it's the same line of work that we have already presented in in the SIG a couple of times at least. So the idea was that we had a discussion with Intel, and I really want to segregate these three different things, which are kind of confusing, I think, when we say Intel's or when we say at least RATLS, and even for I have to keep it limited, I have removed that fourth thing that couple of my colleagues here have worked, and unfortunately they have also named it as RATLS, that is without this minus. So this is only so kind of covering what this RATLS is with the minus. So I have removed that. So I think it's really important to really distinguish the three things, and at least the third one I never knew that it exists, and Mona brought it up that they are doing something with attested CSR. For those who are new, just a quick recap. So there was a project by Shanwai who proposed that a couple of things in the objectives, and one of them was per session freshness, which is not provided by Intel's RATLS. When Mona and Dimitri were presenting long way ago, I think March 2022, I raised this concern that there is no binding between the two things, or very weak binding, let's say, between the two things. And then Shanwai was convinced, and that was one of the objectives of that project. So when I say Intel's RATLS, that's basically the white paper which we have verified and we have talked about in the SIG. This is definitely CCC Attestation 6 project, the interoperable RATLS, the one I just discussed, the two objectives, per session evidence freshness, and the second one that the different variants of RATLS, one by Microsoft, the Open Enclave, Ramin, and so on. So to have them interoperate. If one side is using Ramin, another one is Open Enclave, how do they interact so that they can interoperate? And the third one, as I said, is a fairly new thing. So what they're trying to do, or in my understanding, basically, the picture that Mona posted was something using RATLS. They are trying to embed attested CSR, something inside this. Yeah, so I'm going to talk mostly about the two things that are on the top. So my question first for discussion would be, does Intel have any specs for any of those? Let's say the third is maybe not so much important. I think it's in fairly new stages, but is there a real spec which is internally? Of course, there is none to my knowledge for publicly. Mona mentioned that there are specs in the CCC Attestation 6 repo. I didn't find anything. It's only saying this is the certificate, this is how it's built, and so on, but it never says by specs. I mean something like this, how the protocol is actually working, something like this. What happens in the different stages, like the self-signed certificate is created, and which key is used for signatures, where is the long-term key, and so on. So things like that. Does Intel have any of those for the first two, let's say? That would be my question for Ned.
Yeah, Mona's the right person to ask. Sounds like you've already talked to her about it.
Yeah, okay. So the second one was about the second one, which is the sixth project. So how do we or is there any update on this? So that was one of the objectives, or is it going to be pursued or not?
Can you say more what you mean by per session evidence freshness?
So this was that in the proposal, there was that this RATLS by original RATLS does not provide for each session of the TLS. It will not provide the freshness because the evidence is generated before it even started. And the proposal was to provide this session freshness, the per session freshness, that the evidence is bound to a specific session of TLS.
Yeah, I think this might go back to some last meeting. I started to have a comment and question just as we ran out of time. I think it kind of goes back to, I think we don't all have the same idea of this kind of scenario. I think many people have interpreted like the passport model as one that needs to be like a reusable kind of attestation credential, which means obviously that like what you're describing is intentionally unreusable. It is fresh and unique to the given session. So maybe that's a discussion we need to have.
Mm-hmm.
Right. So the passport is intentionally before the handshake, right? Or is that how you characterize that, or no?
There's two different aspects of passport. Like what I've seen is that the critical part of passport is that it is attestation evidence that's been evaluated before passing it to the relying party. So it's evaluating it with an attestation verifier and turning into attestation results and then sent. And I think, Ned, based on this in prior conversations, you viewed the critical part of it as a reusable piece of attestation results. Right. I think the two different views on what the passport versus background check.
Yeah. So the context that's missing for me in this slide is whether or not we're talking about the attester to the relying party establishing a TLS session over which the passport is exchanged, or is it a TLS session between the attester and the verifier over which evidence is collected, and then after the session is set up, you return the passport, something like that. I'm not sure which.
I think the idea is simple. Basically, from TLS perspective, it's showing that the client as the verifying relying party, which means that it's really both of them joined together. So in this case, it doesn't matter. So I think that the passport and background check wouldn't make much sense here, isn't it? So that would be in the case when there are three different parties, attester, relying party, and verifier. And then you have these kind of topologies that, okay, so who contacts whom and so on. In this case, we are only analyzing from two-party protocol perspective, which is a very simplified case to begin with, having verifier and relying party co-located, a single entity which is doing the verification.
Right, but you're going to have a big difference in terms of what's exchanged, depending on whether you're background check or passport. Background check, you're going to talk about exchanging of evidence, and passport, you're going to be talking about exchanging of attestation results.
Yeah, but why would it make a difference here? Because it's the client is acting as the verifying relying party, so I don't see how passport and background comes in play in this.
Well, it has to do with, like, a lot of the discussion we've been having is how does evidence freshness get tied to the session, the TLS session. And so we have these three approaches. It's before, during, and after, right? We've been spending a lot of time on that. And the whole focus is around, because we need freshness is kind of the point, right? So if you are addressing, if you are using passport model, then freshness is addressed through the interaction between the attester and the verifier, right? And the passport that is minted is its freshness is based on some additional context where the passport is valid for some period of time, and the relying parties accept as a consequence of that context that freshness is measured in terms of the expiry date on the passport. And so it's like the TLS session is just a pipe at that point. It's kind of, it's not providing any additional security properties in terms of freshness. It's providing a confidentiality channel, but it could be an anonymous channel for all that matters, I think.
Yeah. So what, just to recap what you are saying. So basically you are talking about not this case, but rather a case in which verifier and relying party again are two separate entities, But even in that case, I would say whatever that validity of passport is, that would be still replayable within that validity. It reduces the, even if you reduce that to, let's say, 1 month or something like that, or 1 year, I think is one implementation is using as the default value.
Do
So
you mean replay or repeatable?
replay, I mean replay.
Yeah. So if a stale passport is supplied over a TLS session, the expectation is that the recipient will be able to determine that it's stale because the date has expired. It's only in the case where you've, for whatever reason, issued passports that are, you issued multiple passports within the same period of time, and they have different, results. I think is the kind of the corner case that you get into where there's a replay potential. But
Yeah.
presumably that's a short amount of time.
So we do have a stack of hands up. I wonder if we should get some other comments in. I missed whether or not Greg or Deanna had their hand up first.
Deanna's first.
Okay, go ahead, Deanna.
I just wanted to get clarity on what level of attestation we're talking about. Are we talking about saying a node is allowed to join a cluster? Are we saying that a workload on a node that has already joined the cluster, presumably through attestation, is going to attest to the workload and also at the same time chain back through its measured boot despite being accepted at the time of enrollment? It's really a level of like, what is our model of service here?
So I would ask, would it make a difference? Would it make any difference?
Absolutely. So if we're talking about the practicality of checking everything every single session, I think that is going to break down in terms of the usability. The same reason why we have certificate revocation status is allowed to have some amount of time that you can depend on the result, because you can say, okay, I asked the OCSP service that if it's revoked, but it's been a few microseconds, so I'm not sure if I should actually listen to that, right? So it really is the amount of trust you have for the length of time for there to be reasonable changes in state. So in terms of like a node in a cluster, there are things that can change to the measurement that are only related to the host. If we're talking about VMs, right? The host can install new microcode. It can replace the firmware. And these things are specifically supported in the contract of the TEE. So your evidence that you've attested to may be a little bit out of date, and that should be within some amount of tolerance. And then you say, okay, my certificate with that evidence has expired after some amount of time, and it must be refreshed with a new attestation. But I think there really needs to be an understanding that there are going to be levels. We have a node that attests with its CSR, and then it has a short-lived certificate that it can use to attest to the next layer.
Yeah, I think the protocol itself, at least the white paper which we have verified, never distinguishes or never limits that what is the applicability of this protocol. So since it's abstract verification, we never assume any specific case. So I would say it's applicable to both cases. Yeah, and the problem actually is the same that you highlighted, that if something changes, that we have that vulnerability window until that certificate or that token or whatever that is the attestation result is valid.
Okay, so it's the same instantaneous problem of certificate revocation. I don't think that you can really handle that in the maths.
Yes, that's kind of also our conclusion, that pre-handshake is not good, and that's why we are standardizing intra-handshake rather than pre-handshake. And that's why I was quite surprised when I saw the third design, which is still using this. Yeah, because CSR by itself also does not provide any freshness, and I don't think this problem is solvable within the pre-handshake attestation. That synchronizes with our findings.
Requested CSR can have evidence and an extension the way that we have it in the ATLS draft.
Say again, I didn't follow that. So CSR can have
it can have evidence in an X509 extension, and your contract with the certificate authority can require a challenge that would be included in that evidence that is embedded in the CSR. But I will yield the floor to Greg.
Yeah, thanks, Diana. I'm just generally sitting here thinking about freshness and kind of what I've gathered participating in this community over the last 5 years, and also a little bit about the passport model. And where freshness conversations where my more educated peers have led me in freshness conversations always tends to land in requiring a nonce and trying to do things based on time, ends up, dead ending in a, trusted time is either hard or impossible. And beyond that, it's if you ignore that and go down that path a little further, it becomes very, very complicated, I think. So when there's a time, what's it representing? So if you have a time on a verification token, that represents the time that the verifier computed, but doesn't necessarily represent the time that the attestation evidence was generated, for example. So if you round trip a nonce, all the way back to the attested environment, and it comes back through attestation evidence, through a verifier token, et cetera, you're assured of kind of the current, that is fresh from, the time when the nonce was generated in the relying party typically. So I guess I just have two kind of questions to toss out for, be interested in anybody's thoughts on. One is, do we really think that, do we really think that a time-only solution, or how do we think about nonces versus trusted time? And design-wise, they probably lead to very kind of different work. Do we think about only, tackling both, or just one first, order it? And the other is the passport model from the RATS architecture perspective. The way I've, interpreted kind of the suggestion is, it's like a passport, right? You get it once, like I'm using human terms, but you get a passport for 10 years, and then you just, present this wherever needed for the next 10 years. And the passport model with, seems to suggest that that's kind of the pattern. And their freshness kind of goes out the window, or it's very, I don't see how it fits in, right? There's no nonce thing, you're trusting time. It's also, this thing, if you're wary about freshness, you can't really use the passport for long. Is it an hour, 30 minutes, 8 hours, but not too long. So anyway, so I just curious what other folks think about that.
So that transitions very nicely, Greg, and some of the things that I was thinking it might be worth talking about. So, I mean, firstly, I agree that time is tricky. I mean, without nonsense, because wall time is just untrustworthy. You have to decide that you have to trust. That's the whole trust thing, right? Which we all care about. However, certificates generally expect time. And so in lots of use cases, we're going to have to deal with that. There is a couple of problems or I think interesting things around this. The first of which is that lots of certificates and don't allow you to have, or should we say, implementations don't allow basically ephemeral certificates. Anything under a year is a surprise, and anything under a day is almost impossible to implement. That may have changed since I last checked it a couple of years ago, but it's really pretty horrible. However, there's a big question here, I think, about what we're using these for. So these are TLS certificates which are associated with a TEE, because that's the whole point of them, right? So unless we're using them for something beyond that, and we shouldn't be if they're a TLS certificate, you should use a certificate for the thing it's created for, then they've got to be tied to the lifetime of the TE. And how long do we actually expect TEs to last for? And my expectation, I think, is generally a short time. You know, a year sounds insane for a TE to be lasting. A day seems pretty long, and a week seems, you know, almost infinite. So, you know, how long are you going to be keeping one of these around to be doing communications for, given the likely life cycle of a TE? So, you know, this is the sort of thing that's obviously very difficult to write into a mathematical specification, because it's about context and life cycle and usability, and those are the things which don't fit very well. So that I'll stop there, but hopefully that.
But I think wait, just quickly, I didn't track how this related to my question, because Mike, I think you spoke about my question is it's the inception of the TLS connection, at which time the attestation, you know, the trust decision base, you know, for the TE hosted environment is made. So how stale is that, you know, is the information that's used to make that trust decision? There's two different time frames. Once the trust decision is made, how long, and this is captured in the certificate, how long do you trust, you know, how long do you trust it? And the other is, when you're looking at the attestation evidence, how far, you know, how fresh must it be? How far back, you know, how stale can it be? And that's the part, you know, that's the whole attestation verifier pass, you know, that's the part I'm asking about. And that is, so they're two separate topics in my mind. One's the genesis and one's the results. And then as for your question about how long will these things be going? Well, I run a verification service for Microsoft, and we run into TEE. And as you probably know, when you're doing distributed computing, you know, connections can be cached and reused for quite some time. I don't, you know, pragmatically know realistically when, you know, the underlying stack, you know, kicks connections out and forces them to be reset. But from a workload perspective, from a workload perspective, you can have two long-lived workloads that are, you know, speaking securely, communicating securely via TLS for a long period of time. You know, measured in multiple weeks for sure.
Can and should, I think, are very important things to think about here. Whether an AVS should be that long-lived is an interesting question. I don't have a good answer. So yeah.
So can I? Yeah. So I agree with everything that the gentleman just said, and I've been concerned about this verification service. I don't know if now is an appropriate time, but suppose my TEE is changing regularly on a particular service host. I need help verifying that what I get an evidence on is the right stuff. So don't we need a service where, you know, the TEE attestation function is posting the latest hash of what's in my authorized trusted TEE, so that I can verify against it? Did I miss something on that? But I just don't, you know.
Say that again.
Can I respond to that? Or?
Yeah, please.
Yeah, I think there's two events that matter. One is an authenticated or approved update event, which changes the TE.
Right.
And the way that the way you get you retain freshness from that kind of an event is the update entity notifies the attesting environment to trigger them to get another collect, another set of claims. The other update event is an unauthorized update event, and the way that you respond to that is the reference value provider provides reference values that are the current ones to the verifier, and if the unauthenticated update doesn't match, then you can detect it that way.
Mm-hmm.
The tough design consideration is if the attesting environment doesn't periodically check to see if there was an unauthenticated update, it only waits for the notification, then there can be an envelope where there's measurements that are reported that don't reflect what the actual state of the TE is.
Mm-hmm.
And
time
so I think
envelope, you mean?
the time envelope, yeah. So that's really the sort of the question that from the perspective of how do I design my attesting environment securely is how often should I recheck between when I'm notified to recheck.
I think
So just real quick, the
Sorry.
diagram I'm looking at, it's missing the verifier, right?
It's not missing the verifier. The verifier is supposed to be within the relying party. So it's basically a model which is simplistically saying that the relying party is merged together with the verifier.
Okay, I see. I understand. It's certainly if the client is configuring the TEE, they should have the ability to get a hash. So that makes sense in a DevSecOps environment, but I'm not so sure that it makes sense broadly.
There's a scalability challenge if the verifier is in the relying party, which is that now all of the relying parties have to have connectivity to all of the reference value providers in order to and be able to get current updates.
Right. Yeah.
So basically, just to clarify one point, so why we selected this to be model like this. So it reduces the complexity of the background check and the passport model, all that we have been discussing. I'm pretty much sure the issues that we have found will be much more when we have these parties segregated together. And then I do not see any internet draft or anything that is even the internet, even the for the intra thing. So what we are saying is, hey, this is the connection between the two things, and the third one is left alone. Like we don't know what exactly is going on in between that. Is it a normal TLS connection? Is it also an attested TLS connection? If that is also attested, then who is going to start that? So it's kind of a chain which goes back. Then how do we actually do in case of 3 different parties? So we have some rough maps of how it works, but it's never laid down or specified anywhere how attested TLS is going to work with 3 different parties with security provided. And the point about the life of the connections that Greg and Mike were talking about, I think really the point is that depends on the use case, and there might be some use cases, as I believe Greg was mentioning, that could have longer life. And the protocol, when we design a protocol, it should be strong enough that it does not say that, hey, this is limited to this use case, or this is limited to this use case. Even if it is limited to this use case, it should be clearly mentioned that this is the limitation, that this is, let's say, short-lived and whatever, but it's never the case. That's never mentioned anywhere. And while designing the protocols, the priority should be that it should be valid, let's say, for generic cases, and it should be usable for as much possible cases as it can be. And then having the freshness within the protocol itself is a much better way of doing that when we have this evidence being generated within the TLS, which is going to give us much more guarantee than such a protocol will give you. And that window of replay and so on, so that we can actually solve it using within the protocol itself. That's the main point. We do not need to be dependent on, okay, so this is good for this use case, which is very short-lived, where hopefully it will not be changing much, or depend on some, let's say, update mechanisms that Nat was mentioning. I think that the design goal, at least that we have for attested TLS, is to provide freshness independent of whatever the use case is.
Okay, yeah, thank you for that.
All right, so David's had his hand up for quite some time. You go
Yeah,
ahead,
sure,
David.
please go ahead.
Yeah, I think we are talking here about very abstract cases and trying to cover every single use case, but I think the reality for freshness is it's very much based on the evidence you're collecting, right? Because there, depending on the system and the evidence you want to collect, there might not be a way to get any fresher evidence. The best thing you can do, say, for a TEE image is get the hash of the image as installed, no current state of the TEE. So it sounds like in that case that freshness is not nearly as important, because you're locked into the state when the TEE was instantiated, right? It's not. There's no way for you to get a more fresh. Are you going to ask on a TLS session to have the entire image of the TE remeasured at runtime? So I think freshness really does come down to what is the exact use case for it, right? Because the content, like a lot of evidence in a measurement cannot change without, say, the maybe not a lot, but some of the evidence of a measurement can't change without, say, the system coming back up completely, right? You're not going to get a new bootloader measurement without a complete restart of the server that you're connecting to and things like that. So maybe the discussion of how fresh the evidence needs to be driven by what the evidence that we want to collect is, because we're speaking very abstractly at the moment. We're just saying we need fresh evidence, but we don't go into what is that evidence, because the freshness of that evidence they have varying windows, right? You know, the bootloader is fresh for the lifetime of the server, the uptime of the server, right? Things like that. So it's just, I just wanted to project that bit there, that maybe we need to not be as abstract, kind of try and narrow it down to what exactly are the common elements that we would want to figure out for freshness, because that may drive some of these decisions as well.
Yeah, I think it's a really good point.
So
Go
the
ahead.
use case. Sorry, Keith.
Go ahead.
Okay, so I think you are absolutely right. So what we are foreseeing here is basically not the load time measurements or the boot time measurements, but rather the runtime measurements, which could change afterwards. So that's the main driving case for this. So this here could be runtime measurements.
Yeah. So I think Dave's pointing out that different modules or objects in the system have different intrinsic properties about their mutability. So you could have like a fuse that's burned in that manufacturing time that cannot be changed, physically cannot be changed from that time forward. So there's no point in measuring it every 10 seconds or every day or year. It's impossible to change. Okay, so you report that as an endorsement to the verifier that says, here is an object that cannot change, right? You don't need to, it's always fresh, essentially. You have other objects that can change, but only under very controlled circumstances, like a microcode update or something like that, right? In which case you have some intrinsic, or it can only change upon reboot. So all you really need to know is what's the uptime of the system, right? Because you know that it's not going to change until the next reset. So that's fresh, right? If you're within that window. But there is the intrinsic property that says, or that describes what that interval is, right? What is the mutability context for that object. So for
Yeah,
every
sure. Yeah.
right, so for every object there is
Mhm.
a combination of what's its mutability properties, and then within that context, you know, what does freshness mean, right? You have to sort of take the two and put the two together in order to know what's a realistic way to design your system.
Yeah, sure. So just a quick comment. So that um, I completely agree. So that's realistic. But the only issue is that the runtime measurements which could change, and for them, it's necessary to have for their freshness is definitely different, which is also what you are saying. But this protocol does not provide good guarantees for that
I
specific
think,
use.
yeah,
For
but
what
the
are
point
the-
is when we talk about before, during, or after, there's a set of objects for which they are known, they're measured before, and they can't, then they're always fresh. And so it's sort of incorrect to say that you can't have a secure system and have objects that are measured before the handshake, right? Because they're still fresh. So yeah, it is secure, right?
It is secure for those specific measurements which are measured at the
Yeah.
boot time,
Yeah.
but not those who can change on the runtime. That's what I'm saying.
Yeah, it's not
Overall,
clear,
it's not secure, right? So
right? But
overall,
the messaging isn't always clear that that's that's how you've qualified everything, right? And so when we talk about, hey, Intel's RATLS, it's being presented in the context of there's a bunch of objects that are measured before the TLS handshake and are, you know, not stale, right? But it's sort of it's kind of sends the wrong message to characterize it as, hey, it's everything that's measured before the handshake is insecure, because it's not exactly correct. But if you qualify it to say, well, we're only talking about the objects that are highly mutable, then you're saying, well, then what you're really saying is, you know, maybe one of these other approaches is better, but that doesn't eliminate the fact that you still need to collect some measurements that have been created before and exchange them over the handshake. So you kind of need to do both.
yeah, but I don't get your point when you say it's still secure. So that's what I am kind of not agreeing with. I'm saying that it has two components. I definitely agree. Let's put all of them, the boot time ones in one bucket and the runtime ones in a separate bucket. What I'm saying is that it's fine for those which are boot time, but it's not good for those which are runtime. And a protocol is, if it's secure for specific one of those buckets, it's overall insecure, right? So that's what I'm saying. I'm not saying that it's insecure for all measurements. I'm saying that it's for this bucket, it's not
So I
suitable.
define security. I define secure in terms of whether it's fresh or stale. And freshness can exist outside of the context of a TLS channel, right? Outside of the handshake, it could be fresh, both before, during, and after.
I wouldn't agree with that. So how would you do it? So that would be, how would it be possible that how would you put, let's say, how would you input that information to the TLS that this specific session then had this specific evidence?
So, and I think this. Sorry, can I jump in here?
Jump in, yeah.
I'm not sure if I'm next anyway, or is it Keith? But I think this is part of the problem. While I applaud the intention to make cryptographic protocols generalizable, as with my security architect rather than with my cryptographic protocol architect, because I've done both hat on, I think that is very problematic when we are defining a protocol which is based on primitives which do not have properties which support that. We've talked about for instance, rebooting and freshness and these things, which are outside in a Gödelian, it's a Gödel type, way of the set of things that can be known when you're defining the protocol. And I think we have to admit that when we're writing the protocol and say this protocol is not appropriate for these use cases because of these underlying primitives which do not meet the requirements that we need if we're going to define the protocol in this way. And I think that's fine. In fact, I think it's a good thing to have our eyes open about context in terms of protocol definition, because I think it's one of the dangers that we've seen, over the years about cryptographic protocol design. I'll stop.
Yeah,
Is it possible to get an example of what we're talking about with the runtime measurements here? Are we talking about like instantiating a TEE in a writable form and having someone say do an apt-get update in it? Is that the kind of freshness we're talking about? Because I would argue that that's not an ideal. I understand it might be necessary in some cases, but it's probably not an ideal situation where you can arbitrarily have the TEE start installing and updating packages, because that throws like any concept of the root file system measurement out the window at that point.
I don't think that's the type of freshness being. When we're talking about runtime freshness, Usama, correct me if I'm wrong. This is like if you have something like RTMRs on TDX or PCRs on with a TPM, you can have events happening at runtime that are important to measure and convey to know the actual operational state of the system more than just the code that was loaded at launch time. Is that what you're referring to as well, Usama?
Yeah, that's true. RTMRs for TDX and run extended measurements, REM for CCA and so on. Every VM-based TE provides you the facility to have these runtime measurements, and that's what we are discussing about.
And
So
are those appropriate things to be expressed in in TLS, or should they be expressed in a different type of certificate? I think that's one question we need to think about.
Sorry, Mike, say again. I didn't follow that.
Are those all appropriate properties to be expressing via a TLS certificate, or should some of them sometimes be expressed in another format? TLS is a communications protocol. It is not a general content, context, and meaning expressing mechanism. It should only be used for establishing and maintaining communications and not for other things. And it can be overloaded. And I think we're in danger of possibly doing that here.
Yeah, so firstly, for TLS, because all TEs, to my knowledge, basically use TLS for secure channel establishment. So that's what already exists, and that's what is used in all implementations. If you know some other protocol, let me know.
No, I'm happy for it to be used for communications establishment. It's whether you're trying to express a whole bunch of other things on top of that, which are actually irrelevant to the communication channel and should be expressed in different ways. And I kind of feel that with putting anything you might express about a TE state into a communications certificate, which is, we mustn't overload certificates. It's really bad practice.
So Mike, what is it about this that you're concerned that would be irrelevant to the communication channel? Because these runtime measurements can include things like the launch arguments for some inner workload bit of code that's running that you need to trust in order to, or it's part of what you need to evaluate to know whether you want to trust the communication channel at all.
Are you trusting the communications channel, or are you trusting the thing at the other end of it? These are different things. And I've been guilty of this myself. And it's only as we've been having this conversation that I've been thinking about it. So I'm not sure. Yeah, I'd love to see a list of all the things we're trying to assert with the certificate.
So Mike, would you be more comfortable, I think, then with the post handshake attestation model that Usama had talked about before in these cases for like the runtime measurements, where you establish the connection using your normal TLS mechanisms, and then you send this updated evidence across the channel, and you can always abort it if you don't trust it, which I think is what the post handshake was.
I think that I might want to use both, but because one of them isn't a TLS thing, right? One of them is ascertaining what, because trust is contextual, and one of the things you trust is a communications channel, and another is the identity of the machine or the identity of a piece of code or whether the data in it, and those can be conflated sometimes correctly but not always correctly. And you know, I'm quite happy that you're going to be making some decisions just about the channel, but I'm not sure it's always appropriate to decide every trust context based entirely on this, particularly when there are some things we're arguing about. If we're not sure about them, well, maybe we take them out and say, well, they should be tested, they should be verified in different ways. And I'm not sure, and this is why I'm asking the question. I'd love to see a list of all the things. This is a useful picture, by the way, thank you. But of what are all the things we are actually saying we might care about? And do all of them always need to go into a TLS? And I from what we're hearing, I'm not sure all of them always do.
We've long had the conversation or discussion around, you know, what's the endpoint to which the channel connects on both ends. And if you sort of look at the history of TLS and any, you know, secure channel technology, the endpoint, the question about what is the endpoint has always had a lot of sort of hand-wavy discussions.
Yeah.
Right. And so you could say, well, the endpoint is actually the human. And so what I really care about is the passphrase that's in the brain of the human. That's the endpoint. And so I need to use some kind of, you know, e-speak or something that incorporates the password into the secure channel somehow, because it's the human that's the endpoint, right? But we've also said, yeah, but there are also cases where there aren't humans, and so we're talking device to device, and so the device is the endpoint. But then the question is, okay, well, is it the entire device, or is it some part within the device? In other words, do I trust every aspect of the device? That's what's in the TCB of the endpoint, or do I want to be more precise about the TCB, right? And so
I always want to be more precise about the TCB.
Exactly, right? So then the question is, well, okay, so I authenticate the TCB by giving the TCB some kind of unique number like a UUID, but then there's the question of, well, that's great, but that assumes that TCB is immutable and isolated and has all of these, you know, isolation and protection properties. How do I know what the TCB is that I'm talking to? And that starts to be where we get into the conversation about attestation, right?
Yeah, you can do that, but it's difficult, right?
and that's where attestation seems to be addressing what is the endpoint, right?
Yeah, I think that's a very good point. And the one thing's about, I mean, you could say you can prove for some value of proof that the thing is immutable because the piece of code that's in there is unable to do any dynamic loading, for instance, which means that you can have some sort of immutability, but that's a very high bar to meet, and one you're rarely going to want to care about, I suspect, to that level.
Right. What you get is you sort of get a sort of a mishmash of some parts are highly immutable and other parts are less, but they're dependent on one another, so they're inside the TCB boundary, right? And so,
yeah,
right. Yeah. So when you sort of look at the composition of the endpoint in terms of what's attestable, and then you start to have enough information to sort of suss out what are the hard, you know, immutable bits and what are the more mutable bits. And then you're kind of making sort of a hand wave risk assessment based on some combination of what those things are and how they interact with one another.
My favorite type of risk assessment.
Yep, this has been a great discussion. I think we took this, what was you know, could have been a very short discussion at the beginning. I don't think we got through everything Osama even wanted to. We talked about it for an hour, but I think I do need to go ahead and cut it off.
Sure.
So we are nearly at the end of our hour. We don't have further agenda items for the next session. Do people have things that they would like to discuss? We need to continue this.
Well, there's this, right? Yeah. And I think it'd be useful to have some inputs. And that input I suggested of all the things we think we might be talking about, whoever that was last speaking about TCPs and endpoints, having that written up so that we can talk about that and have that as something. These are useful things that we might want to think about. How are we going to express this to the rest of the world? Is it an RFC? Is it in a white paper? Is it just in our minutes? And we shouldn't lose some of this thought. It's really good thought and it's groundbreaking. There are not going to be that many people or other places in the world that are having this conversation, particularly outside particular organizations. And it's one of the things the CCC does very well. So I'd love to see us thinking about how we express this.
Is that going to cover this verifier service idea, or no? I missed it, because I'm happy to contribute. I'm worried about SBOM and the connection of SBOM to the enclave attestations.
That's a whole new question. We could talk about SBOMs.
Yep.
That'd be an interesting topic to talk about if we want to have a conversation about
that. Well, is this thing that you asked folks to write up, is that going to cover this verifier service idea? Because I'd like to contribute some content to that.
So the verifier service, I'm not sure what you mean by that. There's a couple of things we've talked about that. I mean, there's the business models document, which is completely separate to this, which I thought I'd sent to you. Maybe I haven't.
Business model?
What's your email address? If you put it in the thing, I'll make sure you're on that.
mspina@miter.org. Yeah. I'm sorry. I'm also distracted, so I may not have understood. But anyway, when it comes to the verifier service, I am happy to contribute to the write-up.
So I think most of the discussion today wasn't really focused on the verifier service. I'm not sure what you're zeroing in on.
No.
Right. Okay.
So in a couple of weeks, we will be at the ITF, so I will not be available. So maybe somebody else can discuss some of the topic.
So we might have to wrangle some of this offline and get prepared for next week. One of the other co-chairs willing to take.
Is it next week or 2 weeks time?
All right, 2 weeks. Sorry, next session.
Yeah. Okay. Fine. Yeah.
I'll take 2 weeks out from now, Keith.
Okay. Thanks, Greg.
Sure.
Thanks, folks. It's fun. I love these conversations. We do get places, honestly.
Yeah, I know.
I suspect there's another one in 2 weeks.
Bye.
So this is, we have been talking about at some point trying to get together. Sometimes this stuff works better on whiteboards, being able to do it together. And, I'd love to think about how we might do that. And if anyone wants to, host it when we're, wherever we're all going to be, whether it's OC3 or a summit of some type, let's have a think about that. We're discussing that in the TAC as well. So please make sure that if you have interest, let's discuss it there too.
Yep, I like that. Hey, Mike, do you see who signed up with the consortium? Because I did register. I just want to know, do you know when that happens?
I don't know. Please speak to Rian about that. Rian is the one who can check to see what stage that's in.
Okay.
But thank you.
MITRE was already a Linux Foundation member, so
yeah, I noticed that. It's just making sure that we get you onto the. I might be able to find out. One moment. List of members. Let's see if MITRE is listed yet. You're not, so we need to make that happen. Okay.
Okay. Ria.
Okay.
Ria.
Rian, R-I-A-A-N. I think he has sent you emails.
Okay.
If you don't have them, just drop me a line and I'll make sure that we square that, sir.
Okay.
So, speaking of future topics, my Zoom just crashed, and I spent the last 3 minutes trying to rejoin. I apologize. I do want to have a discussion because this is what we're trying to accomplish at work right now. We are trying to accomplish a strong workload identity. And for that, we basically want to use attestation to provision workloads with credentials. And the key differentiator for us and why this is kind of easy for me to sell is because unlike with users, you don't need to provision keys. And it's effectively the workload generates its keys, gets the keys certified, and then we can use even like the previous discussion around SBOMs. We should be able to use it all in figuring out what code accesses what data. But because the tester in TLS is not integrated with identity system, with identity access management system architecturally, we are faced with either brewing our own solution or figuring out how to cobble something together. And again, for us, we need to work in Google, it needs to work in Azure, it needs to work in AWS. So I would like to have a discussion around the end-to-end integration of attestation with workload identity and down with basically all the paths, and basically have some sort of a pattern that we can develop that we can follow and also other institutions can follow.
Well, that certainly plays into the question about where what the endpoint is and TCB. So yeah, let's have that conversation.
Is that something that you could throw in like a outline of the 5 items or something to kind of frame the conversation? And
absolutely, I can put together something, even some sort of draft proposal.
Do we have our own do we have our own email list for this group, or is it on the tag?
There is an email list.
Okay, cool.
There is a list in the
I'll check
on
on
the
it.
website, but yeah.
And also, Greg,
Mark,
maybe
is
you
that
and I
something-
can talk offline about how Microsoft does it, because I know you do it, and I've even worked with Harvey Wilson in the early versions of this, how you integrate with your key management solution. I want to understand what we can borrow from what you guys are doing.
Is this something you could have together in a couple of weeks, or is this longer term?
Oh, yeah, no, not at all. Because for us, it's also a matter of zero trust, and we're a regulated institution, so we believe we can fix zero trust with this as well. So no, it will not take me more than maybe a few hours to put it together, actually.
Perfect.
So will you be here in a couple of weeks, and we can dedicate some of the time 2 weeks out to discuss? Or
Is 2 weeks also IETF?
Oh, I don't know, Mark.
I will check my calendar. I'll tell you in a second. Yeah, no, I'm not constrained. The IETF meeting I want to attend is on Thursday, so yeah, I'll be here in 2 weeks.
All right, so let's unless anybody objects, but let's put that on the calendar for a couple of weeks. In addition, I think to seeing if there's follow-up discussion on today's topic. I think those are the 2 most concrete things we have out there at the moment.
Fantastic.
Great. Thanks, Mark.
Thanks
everybody.
Thank you.
Bye.
Bye.
Nice work, guys.
Cool.
Yeah. Can you see the slides? We can. Do you want a slideshow? Yeah.
architecture.